And you can refer to any book you want to get the formulae if you don't at the moment remember what sine 2 theta is, for example, or tan a plus b is. It's all right to refer to a book. Right, here we go. And both of you got the second question. Is that right?
Yes.
What was the second question? 1 plus 1 by sine theta. So it's 1 plus sine theta by sine theta into sine theta. And so you get is that what we had to do?
Yes.
Yeah, we had to do that. Yeah. Right, that was done. The third one. I'm surprised the third one proved difficult because, anyway, let's see. This was x is equal to a cos theta and y is equal to b sine theta. Yes, and we have to what is that? B square x square plus a square y square minus. Is this what we have to calculate? Yeah.
Mm-hmm.
So this first term becomes b square into a cos theta whole square. Right? And the second term is a square into b sine theta whole square minus. Right? What next do you think? It should be. It's just a couple of steps away now. Did you do this though? Did you get to this point, both of you? And what next could we do? So let's break it up. What next? So this is a square b square cos square theta. This is a square b square sine square theta. You can actually add them up by taking a square b square common to these two terms, the first two terms. So it becomes a square b square and within brackets cos square theta plus sine square theta. You see that?
Yeah.
So you get a square b square here and then minus this. This turns out to be 0. Right? So this is a square b square and that is a square b square. So 0. That was the third one. The fourth one was, what was the fourth question? Prove that sine pi by 8 is whatever that number was. Did you both get it?
I didn't get it.
Shan, how did you approach it? Because you got it, you said.
Yeah, but there was a small problem.
Can you tell me how you started? Just walk me what you did.
I first did I used the equation for cos 2 theta
Which one? Which
equals
equation is that?
1 minus 2 sine squared theta. And then cos 2 theta would be cos 45, which is square root 2 over 2 equals 1 minus 2 sine squared 22.5. And then I just kind of moved everything to one side to get what.
That is absolutely the right approach. I think you started off right. You may have made a mistake somewhere later in the process, but what you described was perfect. So let's get started with that. So if we say 2 theta is pi by 4 and theta is pi by 8. And why do we do this? Why 2 theta? Because this is an angle we know, right? And that's the reason we do it. So this is 45 degrees, and we know this, and this is 22.5 degrees, and we don't know about this. So you have to go from the known to the unknown. That is the first step to recognize. So we can write cos 2 theta as 1 minus 2 sine square theta, right? You can write it in three forms, right? You can actually write this as well. You can write it as this as well, right? Now the point is, why choose this? Why should I prefer this over this and this? Why do you think? Because that is an important decision,
Because you're looking for sine.
right? Why complicate it with this? Right? We want sine, and we know this. So now it's down to just one thing we don't know, this, right? If you go with these forms, then you're dealing with things you don't care about. I mean, you really don't want to know about cos theta. You don't want to have to deal with two things that you don't know about, this and this. So you write it in this form. It is the same thing. So these are not wrong, but they are not very useful in this case, right? So, and that is how you pick this over these two. So having picked these two, having picked this particular thing, so cos 2 theta is 1 by root 2. Is that right? Cos 45 is 1 by root 2. That is 1 minus 2 sine square theta. So 2 sine square theta becomes 1 minus 1 by something like that, right? So far, is that okay? So 2 sine square theta comes over to this side, 1 by root 2 goes that side, and so we have this. And then now we just simplify. So sine square theta is 1 by 2 root 2 minus 1. So sine theta is, oh, did I make a mistake with this? No, I'm making a mistake with the simplification, I think. What is it that we have to prove?
That it equals to half.
Half, yeah. So let's write it in that form. Half 2 minus root 2, right? This is what we need to get to. So somehow we
Yes.
need to go from there, which is correct, to this, right? So we can do that. 2 sine square theta was, so if we multiply both of them by root 2, this is 1 by root 2 into 2 minus root 2. So sine theta sine theta will be 1 by square root of 1 by 4, 2 minus root 2. So sine theta would be 1 by 2. Something like that. Anyway, so, and what about the fifth and sixth? You comfortable with that?
Yes.
Yes.
All right, so let's go to a few more questions of different kinds now. And
Could we also discuss the homework?
yes, of course. So before we go to the homework, I have one other trigonometry question for you. So take a shot at it, right? So this is something different from what we have done. So we have a point A here, and I start my journey from point A, and I travel 500 meters in that direction, right? In the northeast direction, 45 degrees. So in the northeast direction, I travel 500 meters, and that is point B. And then here I start traveling due north and end up here, and this is 300 meters. So from A in the northeast direction, 500 meters, and then north 300 meters. What is AC? Can you think about that?
Is VC pointing to the north?
Yes, BC is north. It's due north, and this is northeast. So this is 45 degrees off from north, and this is exactly north. You don't have to give me the final answer, really. You just have to tell me how to go about it. That's all we're going to do.
We know ABC is 135 degrees.
Mhm.
And then we can just use the cosine rule.
You can absolutely use the cosine rule. Yes. Any other approach? So in triangle ABC, we know angle B. We want AC. We know BC and AB, so cosine rule. Perfect. Anything else? Well, another approach is to say, if I call this point D, right, I can calculate AD. Because in triangle ADB, I know this side and I know the angle. So, if this is theta, now theta happens to be 45. AB cos theta is AD. Yes. And AB sine theta is BD. Yes. So we know AD, we know BD. If we know BD, then we know CD from there to here.
Yeah.
Yeah. So there is CD and AD in a right angle triangle where AC is the hypotenuse. And so there may be a third way. I don't know. Well, there is a third way, but yeah, cosine rule is probably just one step, and I suggested Pythagoras theorem. So, okay, so let's do the homework questions, and if there is anything else you want me to ask, this is the last class for trigonometry. The reason I want to do certain topics before we get to calculus, and calculus will be the you've not done calculus before, I imagine, have you?
We have.
Limits.
Yes.
What about differentiation?
Yeah.
Yes.
And integration.
You've done it all?
And finding the area under the curve.
So you've done all of that. Then it should be, because it is in India, it is in 11th standard, 11th grade that they get exposed to calculus. But if you've done it all, then it should be a fairly straightforward thing. But I wanted to finish 3 or 4 things before we start calculus, because your textbook has a big section on all of these: differentiation, integration, limits, and so on. So before that I want to be I want to make sure you are both very comfortable with trigonometry, some parts of algebra, and then go to calculus, right? So we're going to go in that sequence. All right, so let's get to the homework questions now. So next class we're starting a brand new chapter. I forget what it is, but it is probably uploaded in the system. You can look it up. It's exponential functions. And then we go to logarithms and then polynomials. Okay, so homework questions now.
I'm unsure about my answer for the first question and the fourth one.
One moment. First and the fourth. Yeah, so let's do it. Let's do them all, shall we?
Yes.
Yeah, it's just easier that way. Shanshan, how many did you get of the 4 questions?
I couldn't get the fourth one. Like
Okay.
towards the end, I'm not really sure entirely what to do. And then for 2B, I got 2 answers and I don't know how to choose which one I should be taking as.
2B is an interesting one. Let's take a look at it. We're going to spend 10 minutes on that. All right, so let's start with the first. What is this now? It's a right angle triangle. You know, I'm sorry I did not specify it, but it goes without saying that this is right angle. I hope you both made the assumption. I should have made it quite explicit, but I didn't. So we know AB is 3. We know BD is 4. And we need to find BC. All right. So we can tell immediately that AD is 5 centimeters, right? That's a start. So we know all the sides of triangle ABD. Now let's see what to do. So in triangle ABD, I think this was 4, this was 3, and this is 5. So sine 2 theta is opposite side 4 divided by hypotenuse 4 by 5, right? And So you could start like this, or I think it's more convenient. I'm just thinking what would be the more convenient way of doing it. Or maybe we can write it as tan 2 theta is 4 by 3, right?
I
Tan
did
2
that,
theta.
yes.
Yeah, tan 2 theta. And because we need to find tan theta, right? That was the question, was it?
BC.
Find BC. Okay, right. Find BC. So tan, that is equal to, what is the expansion for that?
Tan theta plus tan theta
That's 2 tan theta,
over 1 minus tan squared theta.
right? So that is our expansion. Now, what we really have is a quadratic equation.
Yeah.
Finally, it comes down to that. So we call tan theta, let's say x. So what we have is 4 by 3 is equal to 2x by 1 minus x square. So from there, 4 minus 4x square is equal to 6x. So 4x square plus 6x minus 4 is equal to 0, which is 2x square plus 3x minus 2 is equal to 0, right?
Yeah.
From that you have two possible values of x. X can be half or x can be minus 2, right? So now since, and now it comes to a little bit of reasoning. Which do you think is possible? Which
The
one should we
half.
go with? Why should we discard this? Why should we ignore this?
Because it'll give a negative value, and we can't use that for length.
Yeah, so you look at the diagram again, and this is where some of the things I said yesterday become important. Theta clearly is an acute angle, right? Because this is a right angle triangle. In a right angle triangle, if this angle is 90, the other two angles must be acute angles. It can't be obtuse or anything else, right? So
Yes.
given that 2 theta is acute, right? So is theta. So we can't have tan of an acute angle being a negative number, right? So if that is the case, why do we get this solution at all? Why do we get minus 2 if minus 2 is clearly not a valid solution? Why do we have to get the solution and then discard it? Because there are rules that apply to algebra and there are rules that apply to trigonometry, right? This particular equation is a quadratic equation, right? It's a quadratic equation. It has no knowledge of trigonometry and the rules of trigonometry. It doesn't know what is an acute angle. It doesn't know what is the range, the domain of these trigonometric ratios. It doesn't know any of those, does it? So when you just plot this trigonometric this thing, you will get something like this. If you plot that graph on an XY axis, you may get something like this. And why do I say that? X equal to minus 2 and x equal to half are the two roots of that quadratic equation. So this particular solution displays no knowledge of trigonometry. Then it is for us to combine our knowledge of algebra with our knowledge of trigonometry and say, this is okay, this is not. Yeah, that is what happens. Okay. So we take one of them and then we go back here. And since x is half, x is equal to half, and that is our tan theta, and that will be, whatever. What was that? A? What were those? DCB. So tan theta is BC by AB. Therefore, BC is tan theta into AB. Yes.
I used cos 2 theta and sine 2 theta, and my answer was different.
The answer was different. Can you do me a favor? Can you WhatsApp what you did to me after the class? You can do that on the group, and
Okay.
I'll take a look at what might have happened. Yeah, because when you, if you describe your solution to me, it's very hard for me to get it when you speak, right? Right. So I will not be able to follow what you've done. So it's best you WhatsApp it to the group, and we'll take a look at it and see what happened. Is that okay?
Yeah. Do I
But
do that now or after
no,
lesson?
after the class, because I'm not going to be able to see the WhatsApp now.
Okay.
Yeah, so we can do it. You can do it as soon as convenient, and I'll take a look at it, and I'll reply on the group so that everybody knows, what happened.
Okay.
See, the approach you took doesn't seem wrong, right? Because it is perfectly all right to say sine 2 theta is 4 by 5, right?
Yeah.
It's perfectly all right. But, something may have happened after that. I'm not sure.
Okay.
Okay. So I'll wait for your WhatsApp after the class. So that was the second one. Now, the second one, A, is quite easy, right? And we have done a problem like this before, if I'm not mistaken.
Yes.
Right? So A is very simple. What about B? How did you guys do B?
I used the cosine rule,
Okay.
Yeah.
and I got a quadratic.
All right. So both of you used the cosine rule and got quadratic equations.
I actually just used the calculator to find the inverse of cos 5 over 6, but I think we were not supposed to do that. So
Yeah, you're not supposed to do that, I don't think.
yeah.
Yeah. So let's do it. This is a question where there are 3 or 4 different methods possible. Maybe we'll discuss a couple of them. Yeah. Okay. So let me draw the same diagram on a fresh screen, and then I'll do it. So there is AB, there is alpha 2, alpha 3, and 5. So we'll start with a slightly different method, right? And then, so if I will, for the sake of understanding, I will flip the triangle over on its side. Okay, like that. Let's make this AB, right? And the angle A is 2 alpha, so it's a big angle. Then B is the smaller angle. So this is alpha and this is 2 alpha, right? And AB is X and BC is 5. And so this is, now the reason I did that is so that if I draw a vertical like this, right? If I draw a vertical like this, then uh, did I flip it over right? AB. Yeah. So you can see that X is equal to 3 cos 2 alpha plus 5 cos alpha. Yeah.
Yeah.
And because this part this part is equal to this part. Those two are equal. And this part is equal to this part. Because we've applied, we've taken the two right angle triangles and applied. This is not any rule really, it's just trigonometric ratios. And then you can solve for x because we know cos alpha, right? From cos alpha, you know cos 2 alpha, so you can solve for x. So that is one approach. Is that all right? Then we will go to the cosine rule and try to do it. We can do it using the sine rule, we can do it using cosine rule, and we can use it, do it using Heron's formula as well. So let's use cosine rule. So it becomes x squared so we'll take AC square, which is a known side, is equal to AB square plus BC square minus 2AB BC cos alpha. Is that right?
Yes.
Now again, this is about making a smart choice. Why did I not write? Why did I not write it like this? Why did I not write it like this? BC square is equal to AB square plus AC. Let's go back to the screen. So all of them are cosine rule applications. Why choose the first?
Because you know cos alpha is 5/6.
Yeah, and this is where you have to be careful to do the the right thing, because these can lead you to a lot of unnecessary complications, right? And so just think about it for a minute, and while the instinct to use the cosine rule is absolutely great, make sure you use the right form of it, right? And then it becomes a very simple thing. What do we have? AC square is 3 square, AB square is x square plus 5 square minus 2 5x, and what was cos alpha?
5/6.
5 over 6. Right, so that is x square plus 5 square minus 2550. Right, and so you can, I think if you simplify this, what do we get? Get something like 3x squared plus 25x 54 plus 48, is it? Is it what you get?
Yeah.
Okay, fine. So from there we came to a quadratic equation, and then you can solve it. And
I
again,
got 2 answers for that, and I don't know how to choose which ones.
what were the two answers you got?
X equals 3 or x equals 16/3. And I used the calculator to find the angles to decide which one to use.
You got x equal to 16,
16/3.
and x, the other one was
3.
just 3.
Yeah.
Okay. And your question is which one to use?
Yeah.
Now, if we use 3, then it would imply that ABC is an isosceles triangle,
Mm-hmm.
right? And you will find that 3 is not a suitable solution because these will not be in the ratio alpha is to 2 alpha, right? So see, just think about it. Let's think this through. Now, if this is also alpha, right? That's what it means,
Mm-hmm.
right? If this is our solution, if x is equal to 3, that means angle C is alpha, right?
Yes.
Because that's an isosceles triangle. So the 3 angles of the triangle are 2 alpha, alpha, and alpha. So what would it make alpha? So 4 alpha is 180 degrees. So alpha would be 45 degrees.
45. So then angle A would be 90 and
Angle
it's
A would be
not.
90, right? Angle A would be 90,
Okay.
right? Now
Yeah.
the problem with that, what is the problem with that?
It's not 90.
It cannot be 90, right? You're trying to describe a triangle where this is 3 and this is 3 and this is 90 and this is 5. How is that possible?
Yeah.
Yeah. So, that is the thing about when we use quadratic equations, when we use algebra with trigonometry, algebra does not understand the constraints of triangles, right?
Mm-hmm.
So you end up with this impossible situation, right? And that is why you can rule it out. The minute you get these two, you cannot rule it out because you don't know at that stage which of them is valid. You don't, because both of them look reasonable. If one of them was negative, you could discard it, but it isn't, right? Or if one of them was, if suppose you got a solution like 16 by 3 and 1, what would you do? Would you discard one of them?
I mean, one, it couldn't be one.
Why couldn't it be 1?
Like, wouldn't it be?
Because
No,
you
you
cannot
don't.
form a triangle with 1, 3, and 5. You cannot. Can you? It will be something
No.
like this: 5, 1. No, sorry. 5, and this is 3. They don't touch each other, right? It's like, is it possible for x to be 2?
No.
No, for the same reason. They will end up being on the same straight line. This is 2, this is 3, and this is 5.
Yeah.
Right? So there are any number of ways in which you can think about triangles, properties of triangles, and a little bit of common sense, and see that one of the answers is okay from an algebraic perspective, but not from a trigonometric perspective. Okay? So that is why we ruled 3 out. But that's great. I mean, the fact that you got to 3 and then you were thinking about, so which one do I pick, is great, right? So this is not 1, it can't be 1. So that's where we find ourselves. So this seems reasonable. This seems okay. So you take that and you proceed with whatever you need to do. Right? So we have looked at
Yes.
2 ways to do it. One is using simple trigonometric ratios. The other is using the cosine rule. 2 important lessons you need to learn here. And I've mentioned them. I'll repeat them so that you remember. One is there are 3 forms of the cosine rule. It's important to pick the right one to make it easy for yourself. Otherwise, it just becomes a complicated mess, right? The second thing is, we have seen 2 examples today, and in both cases, we had to decide which of our algebraic solutions is a valid trigonometric solution. And in each case, we had to decide, right? And there are reasons to understand why we pick one and not the other. And it's very important that you do so, right? Leaving it in this form is is certainly not the complete answer. If I write x equal to 16 by 3 or x equal to 3 and say I'm done, that simply wouldn't be right. Yeah. So that's the 2a and 2b, and then we have the third one, I suppose, is fairly straightforward.
Yes.
Shanshan, did you
Yes.
get that as well? Okay. So
Yep.
we can go to the fourth one, can we?
Yeah.
Yeah.
The fourth one is cos x plus 3 sin x the whole square plus 2. Now there are two ways to do it again, right? One is using differentiation, which we will not do now. Differentiation, right? We will not do this now because that's probably a discussion for another day, right? But it's good for you to know that differentiation is applicable in a situation like this, but we will do it in a different way. All right. So let's take cos x and recognize the two constants. The two constants are 1 and 3. Right? Now, suppose I compare this to sine A cos x plus cos A sine x. Right? I'm comparing it to that. Now, clearly, I'm not saying this. I'm not saying this. That would be absurd.
Yeah.
Right? I'm saying that they are in the ratio 1:3. So I'm saying sine A is to cos A. Right? So then, what we have is a triangle where this is 1 and this is 3, because we are describing tan A over here.
Yes.
Yeah.
Yeah. So this would be root 10. Would
Yeah.
it not?
Mm-hmm.
So what we now have is we can actually go ahead and say that sine A is 1 by root 10 and cos A is 3 by root 10.
Yeah.
Okay.
Mm-hmm.
And then we'll need, so we write this as, so this whole thing becomes root 10 multiplied by 1 by root 10 cos A, sorry, cos, I made a mistake, didn't I? Sin A, this should be cos x. Yeah. So we compare
Yeah.
these two and then right. Can anybody tell me what is the, if sine of A is 1 by root 10, what is A?
18.4.
Sorry?
18.4.
18.4 degrees. You don't need that, mind you. You really don't need that. Right?
Yeah.
But we will use it anyway. Right? So this is root 10 into what would this become? This would become sine x plus. Is that right?
Yeah.
Yeah.
So now what we have worked with is only this portion, right? So we need to add the rest of it back in, which I will do on the next page, right? So give me a second. So we have cos x plus 3 sin x the whole square plus 2. Now, what was inside the bracket has been written as root 10 sin x plus 18.4. So this is equal to root 10 sine of x plus. Is that right?
Yeah.
Thus becomes 10 into sine square x plus. Now we really don't care much about this except that it is a sine function, right? And it is squared. Now, what is the maximum value of sine square theta, and what is the minimum value of sine square theta? What is that? Can you help me fill those numbers? What is the maximum value of sine theta?
1
1
What is the minimum value of sine theta?
negative
minus
1.
1.
But the problem here is it's sine square. So because of the square, even negative values become positive, right?
Yeah.
So we can safely say that the maximum value of sine square theta is 1. No problem.
Yeah.
What is the minimum value?
1. That's
No.
not.
No. So let's say if sine theta is a negative value, right? What happens to sine square theta? It becomes 1 by 4. Right? What happens if sine theta is some other negative value? What happens to sine square theta? It again becomes a positive value, something like this. Right? So if sine theta becomes negative, sine square theta becomes a positive value. So the minimum value of sine theta can be, of sine square theta can be when sine theta is 0. You can't think of anything lower than that for sine square theta, can you?
Is 0 like a limit? Because it can never be 0.
No, what if sine theta is 0?
Oh. Yeah.
Right? The problem is, if sine theta is a negative value, sine square theta becomes a positive value.
Okay.
Right? Sine square theta can never be negative. Right? Sine square theta can never be negative, can it? Because it is a square number. Right? So the lowest it can go to is 0. It can never go below 0. Right? That's the reasoning. So now we have the two things we're looking for. See, the beautiful thing about this is the value of 10 never changes in our expression. The value of 2 doesn't change. None of those change. So we get the highest value of that thing when the sine has the highest value. And we have the lowest value of that thing when sine has the lowest value.
Yeah.
So if we call this expression E, right, max value of E when sine square x plus 4 is equal to 1. Right? And how much does it become? It becomes 12.
Yeah.
Yeah. What is the minimum value of E?
Wait, why is it 12? Because
So this
just
becomes 1.
sine.
So this becomes 1, right? The maximum value is when this is 1.
So confused.
I'll write it on the board. All right. Let's forget about trigonometry for a second. Let's pick a simple geometric algebraic expression and do it. Okay. And then we will go
Yes.
back to trigonometry. So there are two things that you need to understand here. One is suppose A is a real number. A is any real number. What is the minimum value of
0.
Absolutely, right?
Yeah.
The minimum value, and you understand what it means. If you draw a quadratic curve, this curve is like this, where we have a square here and a here. So the lowest value is 0. It never goes below the axis when you draw this on a graph.
Yeah.
When a becomes negative, a square is positive. When a is positive, a square is positive. So the lowest it can get to is 0. Right? That is the first thing. And why did I talk about this? Because we are talking about sine square theta. Right? So it doesn't matter whether sine theta is positive or negative. Sine square theta can only be positive. So the lowest value can be 0. Right? So that's the first thing. The second thing is what is the lowest value of this thing? Now, this is multiplying a square by 10. So 10 is not a number that's going to change. 10 is fixed. We're adding 2 to it. That's not changing. It's a constant. Right? So the value of 10a square plus 2 can change only because a square is changing, not because 10 is changing or 2 is changing. Right? So
Yeah.
if a square goes up, 10a square plus 2 goes up. If a
Yes.
square goes down, 10a square plus 2 goes down. Right?
Yes.
Right? And so when a square has its highest value, 10a square plus 2 has its highest value.
Yeah.
When a square has its lowest value, 10a square plus 2 has its lowest value. Right? So that is what I was saying. And that is what I was saying. When a square is highest, then 10a square plus 2 has its max value. Do you agree with that?
Yes.
Yes.
And the opposite is true as well. When a square reaches its lowest value, whatever that might be, then 10a square plus 2 has the lowest value. But now we know that there are limits to a square. Because it's a trigonometric function, a square cannot be more than 1 and a square cannot be less than 0.
Yeah.
So the maximum value of a square is 1. So this becomes 12. The minimum value of a square is not minus 1. Even though sine theta can become minus 1, sine square becomes plus 1 again. Right? So the lowest value of a square is 0. And at that
Okay.
time, this becomes 2.
Yeah.
Yeah. So the answers to that question are maximum value 12, minimum value 2. Now, the
Okay.
entire trick, the entire thing was to write something like sine x plus 3 cos x or whatever that was. Now, this requires differentiation to do as it
Yeah.
stands in this form. But by writing it as a single angle, sine of x plus a or whatever we did there, right? It's sine of a single angle. Now you know the maximum value for this is plus 1. The minimum value of this is minus 1. Right? And that is the advantage of writing it like this, as a single trigonometric ratio rather than as the sum of 2. If you ask me what is the maximum or minimum value of this, it's very hard to say. You look at it, it doesn't matter what is inside the bracket. You can say maximum value plus 1, minimum value minus 1. And that is the advantage of this form.
Okay.
Right? So that brings us to the end of the homework questions as well. Wonderful. So we start a new chapter next week. We follow a similar pattern. Now, if there is anything you want me to do differently in the next chapter, let me know. More questions, fewer questions, faster pace, slower pace, or anything of the kind. Otherwise, I'll continue in much the same way. I plan to add many questions which are different from what you are seeing in the textbook in the next few chapters, just to make you think differently. The textbook has questions of a certain kind, but the variety is good. But I can think of a few more questions that may help you think differently. Right? So we will be doing more of those. All right. So I guess next week is when I'll see you. Enjoy the New Year weekend. I will see you Tuesday morning.
Thank you.
Thank you.
Bye. Bye.